Thank you, Professor Chinchilla Wan. Let's follow with the agenda then. It is now my great pleasure to introduce our speaker, Professor Chuanpeng Hu. Professor Hu is a leading figure in the push for more practical and inclusive open science practices. From his current position at the School of Physiology at Nanjing Normal University, his work perfectly embodies the spirit of our webinar today. His international experience, from his PhD at Tsinghua University to his postdoctoral research in Germany at the Leibniz Institute for Resilience Research in Mainz for over 3 years or so, gives him a broad perspective on the global research landscape. His team employs multiple methods: behavioral experiment, computational modeling, neuroimaging, and more to study humans' self-concept. But what makes his contribution so vital to his dedication is his dedication to actionable changes. Professor Hu is not only an active executive committee member of the Society for the Improvement of Psychological Sciences, but most importantly for our discussion today, he is the founder of the Chinese Open Science Network, this incredible initiative which counts with over 33,000 subscribers. Fantastic. It's a powerful testament of the demand and need for community-driven support. His presentation today is directly based on the work we will be discussing, as Professor Wang mentioned. Open Science in the Developing World, a collection of practical guides for researchers in developing countries. He will move beyond just raising awareness to offer concrete, gradual steps from building a foundation with open resources to fostering leadership with local communities. Please join me in giving a very warm welcome to Professor Hu. Professor Hu, the stage is all yours.
Thank you, Professor Huang and Professor Severeto. It's my great pleasure here to share our collaborative work about how to do open science in developing countries. Usually we have limited resources. So I changed my title a bit, so make it shorter and more friendly. Basically, I hope to share the experience and tips we have gathered by the 45 authors who all have first-hand experience in doing research in developing countries. So firstly, a bit background about psychology, my field, and myself. So psychology is a field that studies human behavior and the human mind. We try to use scientific method to understand how human mind works and how and why there's some particular human pattern. And we also try to understand the biological and neural mechanisms underlying the human behavior and the human mind. Because of this background, we psychologists always interested in human behavior, including scientists' behavior. So psychology is naturally combined with open science, because open science is basically one practice, one behavior of scientists. So in my research team in Nanjing Normal University, we focus on self-concept, how humans represent themselves in their brain and in their mind. Then comes the question, why should you, maybe you're wondering, why should you interested in open science and promoting open science in China? So it was started from my personal experience. In my first year of my PhD study, I tried to replicate a published study in our field. Basically, it claimed that human can process self-face even without seeing the face itself. Basically, it's studying how human mind work unconsciously. The problem is that I can never replicate the published results. So it spent my 1.5 year of my PhD, and I was very frustrated. And fortunately, my supervisors were very supportive, and they allowed me to change my topic. And lately I started to become very interested in the topic why published studies cannot replicate it. Very soon I found that I was not alone because many published studies was not replicable, which with the hallmark study published in 2015. Basically, a group of researchers replicated 100 published studies in psychological science, so in many different journals in the field, and they found that only 40% of the studies were replicable. So this study and many other relevant events in that, like in 2012 and to 2015, people aware that we may have a credibility crisis. The published results are not trustworthy. And the whole story was recapped very well by a book called Seven Deadly Sins of Psychology. So I'm not going to dive into the details of replication crisis because there are plenty of publications. So the message is that because we have a replication crisis, so as a scientist, we need to change, right? So then the solution for overcoming or addressing the credibility crisis was to be open and transparent. So in 2017, there was commentary published in Nature Human Behavior stating that we should keep every step of our empirical study transparent and open from the very beginning. When you generate a hypothesis, you should register it because if you do not pre-register your hypothesis, then you might be cheat yourself later. And then when you design your study, you should consider the statistical power. When you conduct study and connect data, you should control quality and so on and so forth. So this become all these new practices was recommended by the community. They become the so-called best practices for doing some, for example, best practices for design study, best practices for collecting data, and so forth. All these new practices aimed at improving the credibility of psychological science. And together, people call this group of behavior practices as open science movement. And also at that time, psychologists initiated an organization called Center for Open Science, which basically at the very beginning promotes the open science in psychological science, but then lately then combined with researchers from other fields, it become like a very powerful driver of the whole open science in academia, and also like the Meta Science Conference. In the past 10 years, Center for Open Science tried many efforts to promote open science practices among psychologists and other fields. And they found that to make open science possible, you need to get prepared for 5 aspects. Firstly, you should have some infrastructure, make the open science practices possible. Then you need to have some interfaces to make the open science practices easier so that people can implement those those new practice methods in a very easy way. And then you should have a community. Everyone think that doing open science is the norm, then make the new practices normative. And then you should make people feel that implementing those open science practices are rewarding instead of being published, right? So the journals, the funding agencies, they should reward for the people who doing open science practices. And finally, if some open science practices are truly aligned with the value of science, then we should have some policies that require researchers to do so. So all these 5 aspects are very important for open science. And actually, in the past 10 years in the field of psychological science, we have all these aspects. For example, for infrastructure, the Center for Open Science, they built open science framework. And the CAS in China, they also built a scientific data bank for archive data and sharing data. And Europe, they have a repository called the Zalado for saving data and article and everything. For the interface, I think over the past 10 years, all the interface of these websites are evolving so that making it easier to use. But we also have other interfaces, like we have R packages, Python modules, and we also have a new softwares to implement new practices. For example, software such as JASP to implement Bayesian statistics, which is become increasingly popular in psychological science. For the community part, over the past decades, there are a lot of grassroots network was created and growing. For example, the Society for the Improvement of Psychological Science, which become an international organization for discussing how to improve psychological science and how to increase the credibility of psychological science. We also have a psychological science accelerator, which is a network of collaborators to conduct big team science. Hundreds of researchers come team together to solve one simple question or one important question. We also have a Chinese Open Science Network. So the network we have now. We also have a FORTT, a grassroots network for providing training and educational resources for open science practices. We also have a lot of reproducibility networks around the world to just promote the awareness of reproducibility. And for the policy part, we have new journals. They are dedicated for open science and practices. For example, AMPPS, Advances in Method and Practices in Psychological Science. Some old established journals, they also have new policies to support open science. For example, even Nature, they started to support register report, and leading journals in in our field, psychological science, they support all kinds of new policies. So these policies are played a very important role to encourage and require researchers to implement open sciences. Interestingly, the open science movement started in psychological science was completely aligned with the open science recommendation by the UNESCO. So lately, we psychologists combined work together with researchers from other fields, we promoting open science, like to make science so find new ways to implement those practices to make not only the research processes are transparent and open, but the knowledge that, for example, the knowledge of psychology is open to the society, open to community. So even in like a broader sense. Okay, everything sounds very good, right? We are improving ourselves, and psychologists are doing trying their best to improving the credibility of the field. But if you are a researcher in a developing country and you look all these changes, you may find that the whole movement, the whole open science movement was driven primarily by researchers in the global north, which were developed countries. For example, in 2023, when we writing our position paper about Chinese Open Science Network, we found that most ambassador of the Center for Open Science, which which is like a great community for promoting open science around the world. But most of the ambassadors are from the US and Canada and Germany, so North American and Europe. And for the Society for Improvement of Psychological Science, another very important organization in our field, most of their members are also from the US and Europe, and only few others are from other part of the world. If we look at the organizations, so we identify the leaders or the founders of each of those grassroots networks. We found that most of them are also from the US or the UK or the other parts of developed countries. So basically, the voice of researchers from developing countries are basically invisible. it also created a problem because obviously researchers in developed countries and in developing countries are in different situations, right? Developed countries, they usually have the funding is like the infrastructure is better and the funding is more amplitude, is much they have large amount of funding and also they have better working condition, right? If you worked in Europe or in the US, especially in Europe, they will tell you that you should have a life work balance. I mean, it's an luxury, right, for researchers to have a life work balance because you can only work for a few hours per day. But you come back to China, you will find that most people do not have a life work balance because they have to work for long hours. So as a like a researcher, like worked in both developing countries in China and also as postdoc in Germany, and also have a contact with many other researchers in Europe. I found that we're in totally different situations. Many of the new practices actually have requires extra cost from a perspective of research in developing countries. Basically, if we summarize what the barriers we faced when we tried to engage in open science, we found that we have at least two layers of barriers. Firstly is micro barriers, micro level, which is directly used related to how we engage in open science. These micro facts are time, it's just mentioned, and training, because, for example, many of the new practices requires that you have advanced statistical knowledge, but this part of the knowledge is not trained in our school. And you may also need institute supports. You need a good working condition, and you need a good community support, and so on and so forth. So we found all these factors that contributing to that allow researchers to engage in open science are basically not available for researchers in developing countries. And if we even look like deeper, we will find that some macro, like even more at a larger scale, some factors are constrained our capacity to engage in open science. For example, the infrastructure is in general very bad in developing countries. We are lack of financial support. Geographically, we are far away from the, let's say, the science center, right, of the world. For example, if we want to attend some conference, we always need a very long flight, and we also need to go to another time zone. And we also have language barriers, and sometimes the law and the policies do not support open and transparency of some of the information. And we may have a different culture, right? For example, in East Asia, we emphasize being modesty instead of being assertive. But if you want to promoting open science to even promoting anything new, right? You should be assertive and be confident about the value you are promoting. But in East Asia, we do not value this kind of assertiveness. So the culture may somehow also, for example, reduce the opportunity for being a leader in the international community. So these are the barriers we summarized during our writing process. And of course, the exact role of each fact is not quantified. So we qualitatively summarize the impact of this fact. Even for the best research practices, many of them have hidden costs for a researcher in developing countries. Of course, I believe the costs are they are hidden costs for all researchers who want to adapt these new practices if they were training in traditional way. But the cost is more is higher for researcher in developing countries because we are already in a not well-off condition. So, for example, when you start the recommended practices for the starting point of research is that you should pre-register your hypothesis, which means you should have extra training about the new practices. If you have no idea about what is pre-registration and where you can do your registration, then basically you cannot do that, right? You cannot finish the best practices. If you try to do that, then you need extra time for training. And also, because of our traditional training, we get used to collecting data faster. So when we have like when we finish design the experiment, we hope to directly go to the data collection part, right? Instead of writing the whole protocol and submit it for review. So the conventional front-loaded workflow also like needs some like time to get used to. So I just give one example. Actually, for every best practice in the whole workflow, we need some costs if we want to adapt them. So then the problem is if all the best practices are so hard for researchers in developing countries, how can we start to engage in the open science practices, right? So now we already marginalized. And then we also have difficulty to engage in these practices. Basically, if we do not take action, we will like forever be marginalized. So from our experience, even we are in a very bad situation, we can still do something, like do something slowly to engage in open science, practice learning these practices, and slowly we engage and being the contributor of the community. And finally, we may have the chance to be the leader of the international open science community. So the 45 authors of our team, we discuss a lot, and finally we form this kind of four-step practical guide for engaging open science. So we try to be very practical and considering the situation we are working in, and so that we hope that we also have a very long supplementary material to directly providing the resources for researchers. So here I only give you some examples. If you are interested in, you are welcome to read our paper as well as the supplementary material, which is really a useful checklist. So because we want to be practical, so we hope that our guide can be useful for researchers, especially for early career researchers without much resources, can start to build their career and then slowly contribute to the community and become the leader. So we have 4 levels, as you said, as you just meant, you can see here. And firstly, we build a solid foundation for our career and being a good researcher, and we can use the open available resources to achieve this goal. Then we slowly start to become experts in open science, which means we can slowly implement those best practices in our research after we already have some experience in doing research. And then we can contribute because contributing to the community often means that you need some resources, right? You have something to contribute. But of course, as I will show you later, everyone can contribute actually. And finally, when you get used to when you are recognized or are familiar with certain community, you have the chance to nominate yourself as a leader or even start your own community. I think the foundation part is most important for early career researchers, such as when I was in my PhD, right? I hope that I can like get some tips or guide from who has some experience, help me to navigate the academia. So nowadays, because of the open science movement, many of the resources are already available online. So we can make good use of these resources to build a solid foundation for our research. So here I only present the four aspects, but I think the openly available resources is much more than that. As a starting point, I think if we try to start a new project, the first thing we need to do is to, as Newton said, right, we should stand on the shoulder of the giant, which means that we need to know what has been done by previous researchers. So we need to read papers, right? Read existing documents. For researchers in developing countries, it can be a difficult thing because maybe our institute do not have not paid for certain database, and we cannot read those papers because they are within the paywall. So nowadays, we have because of the open science movement, many of the papers have open access or they have open access version. For example, many researchers in psychology now post their manuscript on preprint service such as arXiv, scIRCiv, bioRxiv, and etc. And we can access the full text of many papers in these platforms. Also, there was a very good website called OnPaywall. Basically, it get together the paper, the full text of papers using legal methods. Of course, we have the green area, right? The Sci-Hub, which still, I think is still alive. We can still use it to get the full script of some old papers. And also, there are some other tips we mentioned in our paper. For example, you can write an email to ask the author to provide full text for you. Here, I want to mention that even we are saying that open access papers is great, but I think we should distinguish between no cost OA and open access with very high article process charge by the publishers. So here is an estimation for how much money does the Chinese did the Chinese researchers paid for a single journal, Science Communications in 2024. So it's a huge amount of money, and we researchers basically transfer taxpayers' money to publishers. This actually is not ethical, right? And if we read some papers and then we have some idea, we may want to test our ideas, right? Usually, we need to connect our own data, but as a researcher in developed countries, you may not have the equipment or the funding resources for collecting your own data. But the good news is that there are so many open data on the internet, so you may test your idea using existing data. For example, there are open science framework. On that website, you can find many data related to human behavior and psychology and related fields. Also, there are a website called openneural.org, which has many published the data linked with many published paper, including like EEG, FMI, etc. Also, Zolado has many published data and scientific data bank. As I mentioned before, it also stored a lot of open data, and we also have like large-scale survey or large-scale studies that was supported by national funding agency. Many of them are also openly available. You can use them to test your own hypothesis. So that's the data part. Is like a raw material for doing research. Then you need some like a method, Like you need some a specific way to cook the raw material to make it research work, right? At the very beginning, you may not experienced in writing code and using certain methods, but nowadays, because of the open science movement, many of the scripts and code are openly available on the website as well. For example, in GitHub or GitLab, you can find many public projects. All the data, all the code are already there. You can just learn the method by reading the code and change it for your own purpose. And usually they have a very flexible license, so you can change the code. Maybe you acknowledge you have reused their code in your paper. And finally, maybe if you do want to collect your own data, right, then you may need some materials. So in this case, in psychology at least, we have many materials that are openly available as well. For example, when you want to conduct a study that requires facial expressions as your material, you may find many existing database that provide material, standardized material for your study. So that's a very great resources brought by the open science movement. And also as researchers in developing countries, we may not have enough money to buy the subscription-based software or some like high cost hardware like the EEG and the eye tracking stuff. But now we have most of the software we're using in doing research have a open source version. So in our paper, we have a list of free open source software for doing research, especially for psychology. For example, we have a software for data connection, and we have picture editing, and we have a data analysis software. For the hardware part, we also it's not like as many as the software part, but we still have some hardware that are available. So basically, if you use open hardware, then the cost of the experimental equipment might be reduced to like 10% of the original price. So it's a huge advantage for researchers in resource limited settings. And as students, you can also learn a lot of new skills through the open education resources. I think there are many of us already learned statistics and how to program using the existing educational material on the internet. For example, YouTube has a lot of great courses open from the prestigious universities, right? Specific to open science, for example, if we want to use the latest statistical methods, we can always find some open educational resources there. For open practices, we may need the skills to share our data, to organize our data, right? There was a very nice online book called Turing Way, which included many aspects of open science. So using these open education resources, we can improve our skills in doing open science. So one caveat here is that language barriers still exist, which means we need to read and listen to English materials. So using the openly available resources, including data, software, code, and everything, we may be able to slowly build our research foundation. We can publish a few papers, and we can, for example, in China, if you publish a few papers, you may able to obtain your PhD degree and being competitive, relatively competitive on job market. And then maybe you will consider how to improve your practices so that they are aligned with the best practices as recommended by the international community. And then we can slowly, gradually to implement those practices in our own practice, own research, and we should do it carefully, and we should tailor it for our own background. But we should never stop trying, because the best practices themselves are also evolving. So here I gave only a few examples about the new practices are recommended. The most difficult one might be the registry report. It is a completely new form of publication, which means you need to um, write your research proposal and then submit it somewhere and get reviewed. Once the reviewers are satisfied with your proposal, and the platform or the journal will say that, okay, we will accept your paper in principle if you implement your study exactly or nearly as exactly as you have planned, then you can start to connect your data. And then once the data was connected and the statistical analysis was done, and the full paper was written, then you can submit it to the journal regardless of the significance of your results. The journal will accept your paper. Because it is completely new, it was quite difficult for researchers, especially for medical researchers, to adapt these practices. So my way is that we need to take this slowly. So firstly, you should understand why it was recommended. So the registry report was recommended because it as a mechanism to against some like existing biases in our current research practice. Those biases actually compromise the trustworthiness of our publication. For example, there was a publication bias. Basically means that researchers, reviewers, and editors and the journal, they will favor they will prefer a paper with significant results, but they will reject, or with high probability to reject, a paper without significant results. In this case, actually the editor, the journal, they filter out those true negative results, right? So it created very promising illusion of the whole field. But public registry report will reduce the publication bias by blinding the reviewers and the editors from the results, because for registry reports, they already reviewed your plan without seeing the data. So if the plan is great, if the research question is good, is a very important one, then the journal will accept your method and your research question. Then even if you get negative results, your paper will still be published, which means the negative results can be published in this way. So just give one example, or one issue the registry report try to address. So if you read some papers about the registry report, you will find out that registry report has its own very good reason in the current research culture. That's why many people advocate it. Of course, it sounds like that you lost your flexibility to explore, you lost your freedom to do something else during the research, right? But this is kind of misinterpretation or misunderstanding of registry report. Actually, our recent survey found that for we asked respondents in both China and Nigeria to report the barriers they faced in implementing registry report. We found that for people without any experience in registry report, they found that they would report that registry report limited research flexibility. But when you have some experience, so the experience group, much less people report that registry report restricted your freedom. So there are many misunderstanding about these new practices. So understanding why it was recommended is very important to accept this new practices and study to practicing. And if you already had learned a lot about Regis report, then you may can practicing, right? You can start a very simple Regis report or registration. For example, you can conduct a replication study by Regis report, or you can just participate in big team science projects. Usually these projects are using Regis report. So you can learning the practice by being collaborators of others or starting a very easy one, right? And then you might get some first-hand experience with this new format. And then maybe in your next project, you can start your own Regis report. So which means the whole idea here is that we need to, for the completely new practices, we can start it slowly. Okay. So for me, the first Regis report in our group was published like last year. Actually, I already know the existence of Regis report in 2017. So from I knew the idea of Regis report to my first publication, it was 7 years. And for the other ideas, of course, we can also start slowly. And for example, managing data and the code and computation environment and everything, we can start slowly and then get and improving our own practices when we already have some experience. Also, we can publish with open access. I would recommend if you do not have enough funding support, you can either apply for waiver for the APC, or you can try the Green OA, which means that you choose a subscription-based journal, but you post your final manuscript on some preprint platform, so readers can still read your paper just in different format. And then when you already get some experience in open science practices, or you have some like already published a few papers, you somehow survived in academia, right? With some published papers, with some experience, and also recognized, or you get familiar with open science practices, you may also consider contribute to the community. There are many different ways to contribute to the community to make the community better. But the tips here, well, from our own experience, is that we always need to balance our time and efforts to choose between either dedicate our time for contributing to the community or doing our own research, because sometimes they conflict. In our paper, we listed many different ways to contribute to the community. I'm not going into the details here, but I will briefly go through them. So first way is that we can conduct meta research. Basically, we're using scientific method to evaluate the studies in our field, whether they are good enough, is there any aspects we can improve, or we can evaluate the reproducibility of published studies. For example, we can conduct a replication study and test the generalizability of certain studies, or we can evaluate the computational reproducibility of the published studies. Currently, evaluating the computational reproducibility is avoided by the community, or at least by some journals. But as early career researchers, I also remind that you need to think twice before you publicly criticizing others' results, because it might be sometimes it might be very tense, and we may need to do it strategically. And we can also engage in open source software development. Some of the we can do that like in a very simple way. For example, we just ask some questions in the forum, right? or on GitHub issue, we have some new. We record our questions and ask people who answer questions. We can also improve the documentation of those open source software because, as you know, everyone is so busy, right? So even for the developers, they are so busy that they often do not have time to make the document perfect. But as a newcomer to or the new user of a certain open source software, you can improve the document. At the same time, you are learning, right? Or you can just write a tutorial about open source software. You are teaching people to use it. This is very helpful for promoting open source software. Or you can, if you are more skillful, as your expertise increasing, you can also create new features for existing software. For example, earlier this year, our group actually created some new feature of existing software for that are widely used in our group, in our field. Or you can just create a new software or package. For example, a new R package or new Python module, right? So here are some examples. This example is by Dr. Lu Zitong. He wrote a tutorial for using the Python modules for analyzing EEG data. And you can also curate some small-scale resources for you specific fields. You can like curate data, code, or materials so that people in your field can benefit from these resources. For example, like a few years ago, a group of researchers, they curated a database called Confidence Database. Basically, they put together everyone's data and in a similar way so that there are like thousands of participants' data and can be used by a whole community. Even this kind of efforts is very helpful to the whole field. Inspired by this project, actually, our group are starting a new project, also pulling together the existing data related to self-concept. Of course, you can share your own tutorials as open educational resources. So here are some materials that I shared in Chinese. And the tips is that, as I just mentioned, we always need to balance our time and efforts. And finally, you can also contribute to the community by being volunteers or share and reposting their announcements and newses to amplify the impact of the community. That also helps a lot. And finally, if you already there has a like a solid foundation and doing good research and also familiar with open science practices, you can also nominate yourself for the leadership in current communities. For example, our Chinese Open Science Network, or CIPS, or OHBM Open Science Room, and many other grassroots network. This kind of network, maybe they will call for new candidate for the leadership, and you can always nominate yourself. You can also start new communities for if you feel that okay, there's no existing community cover my field, but it is very necessary. So you can start your own community. For example, in our Chinese community, we have like a reinforcement learning mind club, which was initiated by Dr. Fang. They focus on exchanging ideas about reinforcement learning. We also have like a diffusion model journal club, which initiated by my PhD students Wang Ke, Pan, and this club focus on reading papers related to drift diffusion model, a specific computational model used a lot in our field, and also others. And also in our paper, we highlighted 3 different community in different developing countries. So as you can see here, actually researchers in developing countries, even we are facing quite a difficult situation as compared to researchers in developed countries, we still can do something, right? And some of the grassroots network actually can have a strong impact for the local community. And finally, if you become a senior researcher or like a senior faculty member in your organization or relatively high-ranking position in your own organization, you can promote open science within your own organization to help the change, right? For example, you can integrate open science practices in your teaching, in your supervision, and or in the hiring policy. But of course, it will depend on your own position and what you can do. Our suggestion is always that just tailor your strategy based on your own background. Don't commit it, because sustainability is equally important. So basically, that's the practical guide. I think I'm a bit out of time, running out of time. So the next step, actually, the next step is mainly for me and maybe the Chinese Open Science Network. As Professor Huang mentioned, we're starting a new journal called Open Science. It would be a multidisciplinary journal, and it will support open science policies. And we also hope that it will become a platform for researchers in Global South, in developing countries, so that our voice can be heard. And we hope to amplify the voices from researchers in developing countries. I also thought of extending our practical guide as a new book and including more and updated resources so that it can be a handbook of for researchers in developing countries for doing research or doing open science research. And I appreciate the efforts and time for all my collaborators of this practical guide. They're from different countries in the world, and we coordinate through the internet and Zoom meeting, and it was not easy. So I really appreciate that everyone in for their time, and I also really thank my current employer. So even though I'm in a department or school of psychology, still they support me to do open science. And finally, all my collaborators over my past few years. Thank you all for your attention.